All right, let's do this. Okay, so let's look at this question. A ball rolls down a ramp so that its distance s from the top of the ramp after t seconds is exactly t square feet. What is its average speed? And after 3 seconds, what is its average speed after 3 seconds and instantaneous speed at 3 seconds? Okay, let's look at what it's talking about. So you have a ramp, you have a ball. All right, so let me ask you. At the beginning, when the ball is on the ramp, what is the speed? Zero, because it's not moving, right? Once you let the ball go, what's going to happen to the ball? Speed up, it's going to roll down, right? This is all very intuitive. It's physics, but it's just like logic. It's going to roll down, and then it's going to speed up. All right, so the question is, what is the average speed after 3 seconds? So starting from 0 till 3 seconds, what's the average speed? And what's the speed at 3 seconds? So those are the two questions we had to answer. What's the average speed between 0 and 3? And then what is the actual speed at 3? Okay? All right. Let's talk about speed or velocity. They're not actually the same thing, but for now, let's just say they're very similar. What is speed? Yes, distance over time. Very good. Okay, so distance over time, however, it is the change of distance over change in time. Right? So distance over time, but not quite. It's the change in distance over change in time. And this triangle is change. I'm pretty sure you've probably seen it in chemistry, right? That is delta. It's the Greek letter delta. It means change. So the change in distance over change in time, or a lot of times we write it as change in s, because s is distance, and then over change in time. All right. So, okay, we have two different things. One, average velocity. So average between 0 to 3 seconds. And then instantaneous velocity is at 3 seconds. Okay, so those are two very different things. One is the average, one is at that instant. Okay, this is a very key part in calculus. So average speed is the change in distance over change in time. Well, the change in what distance? Between what time and what time? 0 to 3. So it's the distance at 3 minus the distance at 0 over 3 minus 0. Right? What is the distance at 3? 9. Okay, so how did you know that? Let's look at the question again. This ball rolls down the ramp so that its distance s is exactly t square feet. So distance is exactly t square feet, meaning as it rolls down the ramp, if it's at 1 second, it went down 1. If it's at 2 seconds, it went down 4. At 3 seconds, it went down 9. Kind of like that. Oh, yeah?
Like how far it traveled?
How far it went down the ramp. The distance it goes down the ramp is t squared. Okay, so then s of 3 is going to be 9 because it's 3 squared. Yeah? 3 squared minus 0 squared over 3 minus 0. That is 9 over 3, which is 3. Yes? Okay, what is the actual speed at 3 seconds? Well, the speed is change in distance over change in time, right? Okay, so that is distance at 3 seconds minus distance at 3 seconds over 3 seconds minus 3 seconds. What is that? 0? 1? 0 over 0, right?
Yeah.
What does that even mean? It is not undefined, but it has a special name in calculus, but we'll talk about that later. Basically, we don't know. So, does that mean there is no speed at 3 seconds? No, obviously you know there is speed at 3 seconds, but how come we cannot calculate? Right? Because speed at that moment there's no speed? That makes no sense. So basically the way we defined it, we cannot figure it out. Therefore, we need calculus to help us figure this out. So here's what we do. We don't know what's going on at 3 seconds because there is no gap. Right? At 3 seconds, it doesn't have a gap to calculate. So we're going to force a gap. We're going to say from 3 to 3.5 seconds. We can calculate that. Change in distance over change in time. So distance at 3.5 seconds minus distance at 3 seconds over 3.5 minus 3. We're trying to calculate the average speed between 3 to 3.5 and trying to figure out what that is. Okay, so how do we figure out the the distance at 3.5? What's the distance at 3.5?
Squared.
Yeah, 3.5 squared. So go ahead and figure out what is the average velocity between 3 to 3.5. Did you guys calculate it? What's the average velocity between 3 to 3.5? 6.5. Good. All right. So we don't know what's going on at 3, but 3 to 3.5, the average velocity is 6.5. How about we make that distance a little bit shorter? So 3 to 3.1. 3 to 3.1. Now I'm getting closer and closer to 3. Okay, so change in distance over change in time. Distance at 3.1 minus distance at 3 over 3.1 minus 3. So what is that average velocity? So calculate it. What is the average velocity between 3 to 3.1? 0? 6.1. 6.1. All right. That's pretty good. How about we bring it in even closer? 3 to 3.05. Change in distance over change in time. Distance at 3.05 minus distance at 3 over 3.05 minus 3. So I'm getting closer and closer to 3 because I don't know what's going on at 3. I can't subtract itself, and I keep getting 0 over 0. So I'm going to try to create a little gap between 3 and something close to 3. That way I can calculate it. So I'm getting really close to 3. I'm at 3.05. So what is that number? What is the velocity? Huh? 6.05. So I can keep doing this, right? I can keep making it really, really close, like 3.00001. So what do you think the number eventually will become? 6. You can see this, right? It's going to be 6. Okay, so what are we actually doing? We are taking the change in distance over change in time. And what we're doing is we are trying to get to 3. We're trying to get to 3. And we are basically saying it's some t, distance at some t minus distance at 3 over t minus 3. We're basically calculating that average velocity, right? We're taking a distance at some time t, and then we're trying to subtract it with distance at 3 and so on. And what we're doing is we're trying to bring t really close to 3, and that is what we called limit. We're trying to bring t to 3. Does that make sense? We're trying to get t to get really close to 3, and then we call that limit. And if you recall limit when we talked about limit a long time ago, it's never at 3, it's just getting to 3. Yes, like the end behaviors and stuff like that. All right, let's look at it. Well, what is S of t?
Oh, t squared.
T squared. We're trying to see. Okay, S of t is t squared. And then what is S of 3? 9. Let me rewrite this. Okay, limit as t goes to 3. T squared minus 9 over t minus 3. Okay, so what happens is if I put in 3 right now, what's going to happen? Undefined, 0 over 0. So what we're going to do is we're going to be a little bit clever and get rid of the part that's creating the undefined part. T squared minus 9, can I factor it?
Plus 3 minus 3.
Yeah, t plus 3, t minus 3. Okay, you can see that this is going to cancel. So limit as t goes to 3 of t plus 3. Now, can I plug in 3 and not get something with a 0 in the denominator? Yes. So that is 6. That's how we get 6. Okay? So when we are trying to bring t really close to 3, this whole thing becomes 6. And then when we evaluate it with this limit notation, we do get 6. Okay, so this is the calculus stuff. And let's define it correctly. All right, in calculus, there are 3 big things. The first one is derivative. And then next week, we're going to talk about 2 and 3. The first big thing, derivative. What is derivative? What you need to remember is derivative means the slope. So when someone says derivative, it means slope. Slope of what? Slope of the tangent line at a given point of the function. All right, derivative means the slope of the tangent line. All right, let's talk about tangent line versus secant line. If you forgot. That's back in geometry, you learned this. So if you have a circle, let's draw a better one. You have a line like this, and you have a line like this. Okay, talk to your partner. Which one is tangent? Which one is secant? Okay, talk to your partner. Which one is a tangent line? Which one is a secant line? It's been too long. Try to recall 2-3 years ago. Don't remember? I hope you kind of recall something. Oh no. Okay. All right, let's guess. How many people think tangent line is the red one? Red one. Okay. How many people think tangent line is the green one? Okay. All right. You're correct. Tangent is this one. Secant is this one. Okay. Now talk to your partner. What's the difference between tangent line and the secant line? Your partner. Okay, what's the definition of a tangent line? Only touches 1 point, correct. And then secant line, 2 points or more, it depends. But yes, secant line touches 2 points. So that is the very important thing between tangent line and secant line. So derivative derivative is the slope of a tangent line. And then the average rate of change, which is this one, that is the secant line. So let me write this down. Okay, derivative is slope of tangent line, and then average rate of change is slope of secant line. Okay, so we're gonna look at the same graph that I gave you on the first page, but we're gonna look at it a little bit differently. Let's say that I choose 2 points on this graph here, just randomly, A, B, and they correspond to these 2 points. Okay, so I have two x values, A and B. What is the y value of this point A if this function is f of x? If this is x equals to A, then this y value is what? Yes, f of A. Okay, if this point is B or x is B, then, what is this y value? F of B. Let's say that I draw a straight line through these 2 points. Is this a secant line or a tangent line? Secant line. Why a secant line? It goes through 2 points. Okay, good. What is the slope of this secant line? What is the slope of the secant line? Can you find the slope of the secant line?
Yes.
Yes. You have 2 points. You can always find the slope of 2 points as long as that line is straight, linear. It is a straight line. So how do you find the slope of this line?
F over B minus F over A.
Not quite. Okay, maybe talk to your partner. Write down something. What is the slope of the secant line? What is the slope of the secant line? I am going to give you a hint. Slope is change in y over change in x. Did you guys learn this way? Change in y over change in x? Yeah, y2 minus y1 over x2 minus x1, right? So how do I apply that to this line? Answer, f of b minus f of a over b minus a, correct? Yes. Okay, so this is the slope of that secant line. Okay, so this, let me just write it here so then we know it's different. Okay, so this is the slope of the secant line, and secant line always has 2 points, so it's through the 2 points A comma f of A, and then B comma f of B. Now let me ask you another question. Can you draw a tangent line through A only? Can you draw a tangent line that only goes through A? Yeah? Okay, go ahead and draw what you think the tangent line is going to look like. Draw the tangent line that only goes through A. The tangent line that only goes through A. So tangent line only goes through 1 point. Something like this, right? Okay, let me ask you another question. What's the slope of that line? Slope, you need 2 points, right?
Yes.
We only have 1 point. We don't know where the other point is. We can guess, but that's a bad idea. So what should we do? Derivative? Yeah, but we don't know how to do the derivative yet. So, huh? Yeah, it's just like what we did before. So what we just did with that ball falling down the ramp is what we're doing. I'm going to show you right now. So what we're doing is we cannot figure out what the slope is at that point. So what we're going to do is draw a bunch of secant lines. But we're going to bring the secant line really close to A. So what's happening is, I don't know what's going on here, but I'm going to draw a line through here, 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 here. And then as I get closer and closer to A, I am at my tangent line. Does that make sense? Okay, so that is calculus. Secant line, that's algebra 1. Okay, bringing it all the way to just one point, that's calculus. Okay, so now we have this line, but then we can't really find it except we have to use limit. Okay, so let's write down the limit method. So let's say that we have this point that's x, and what we're doing is we're trying to bring x really close to A so that eventually it is at A, kind of at A. So then we can say that the slope at A is the derivative at A, and then we put a little mark prime. That means derivative. So the derivative at A is equal to the limit as x goes to A, because we're trying to bring x really close to A, of the slope. What's the slope? y2 minus y1 over x2 minus x1, right? That's what slope is. But this form is not common. Most common way of representing this is using something like this. So we're going to say that this gap here is h. So this distance is h. We're going to reduce that distance down to 0. We're going to reduce the distance between those 2 points down to 0. So we would say something like this. F prime of A is equal to the limit as h goes to 0. Instead of x is the same thing as saying A plus h, right? The location of x is the same as A plus this space h. Okay, so then this is saying f of A plus h minus f of A over h. Okay, that is the formula you have to memorize. And that's the formula that everybody uses. Okay, and this is the slope of the tangent line through just one point, and that point is A f of A. So that is the slope of the tangent line through x equals A. Only at one point. What it?
Will they give you H? Like when you're
H is irrelevant because you always bring H down to 0, so it doesn't really matter. Okay, so now that's the derivative at a point. Definition of derivative is derivative of the function, meaning what is the slope at every single point of this function. So instead of A, we're just going to put x. And then it's the same formula, except every A that you see becomes an x. Okay, so it looks like there are two formulas, but it's really just the same thing. One is the function, meaning x is not defined. The other one is at a point, so then x becomes A. Okay, you guys are doing pretty well, I think. Or you're pretty lost and then you're not sure what to do.
What is it class H? I can't really see the point.
F of A? Sorry.
Oh, F of A. Oh.
How do we solve that though?
Great question. Let's look at an example. So let's say that this function is 2x squared minus 3. First, find f prime of x. Second, you find f prime of 4. All right, let's do this. F prime of x, meaning what is the derivative of the function? Meaning what is the slope at every single point? Okay, let's use the definition of derivative. Limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so you have to memorize this. If you don't memorize this, this is kind of impossible to solve. All right, let's make sure that you understand how to solve this. So let's say f of x is 2x squared minus 3. What is f of 0? Minus 3, how'd you know? Plug it in. Okay, what is f of a then? 2a squared minus 3. So what is f of x plus h? 2 minus 3. Okay, so that's what we need to do to plug into here. So that's what it's saying. Plug x plus h into x, into that function. Okay, don't lose your limit. Your limit is very important. You gotta keep that there. Okay, so 2 times x plus h squared minus 3. Okay, that is f of x plus h. What is f of x? Okay, 2x squared minus 3, so minus 2x squared minus 3. Please make sure you subtract the entire function. That part is also very important. If you don't do it right, it's not going to work. Okay, over h. Up to this point, it's calculus. After this point, it's algebra. Okay, from this point on, it's just making sure your algebra doesn't break down. Okay, we're going to simplify this by foiling in our head. X plus h squared.
x squared plus 2xh h squared.
Good. Okay, minus 3 minus 2x squared plus 3 over h. Okay, we're going to distribute, combine like terms, simplify this. Okay, limit as h goes to 0. 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 over h. Why am I doing all this? Because at the stage, at the second line, if you plug in h equals 0 in this whole thing, what's going to happen? Undefined, 0 over 0, right? So then we can't solve. So what we have to do is try to simplify as much as we can and then see what happens. Okay, at this point, I want to combine like terms. 2x squared and 2x squared cancels. 3 and 3 cancels. So limit as h goes to 0 of 4xh plus 2h squared over h. Okay, what's going to happen if I plug in h equals 0? Because limit is when h goes to 0. So what happens if h is 0? Yeah. Actually, there's a name for that. So 0 over 0 is called indeterminate. Oh, what's going on? Indeterminate. We don't know. So it means we don't know. It's not undefined. It's we don't know. So anyways, you'll learn that next year. Okay, so we can see that h is actually, I can cancel out h from the numerator and the denominator, right? So limit as h goes to 0, I can see that I can cancel out all the h's, and they should cancel out. Now can I plug in h equals 0? Yes. So this is 4x. So it's saying that the derivative of this function is 4x, meaning if you want to figure out the slope of this function at every point, it's just 4 times the x value. Yeah.
How did you get 4x?
So at this point, the second to the last step, you plug in h equals 0.
But the step before that, how do you?
Oh, the h cancels.
Oh, okay.
Yeah.
So you're never getting an actual number with this if it's like that complicated. It's just.
No. So there are two different things. One, figure out the slope at x.
Point. Okay.
Yeah, this at a point, so they're different. Okay, so B. What is the derivative at 4? Meaning, what is the slope at x equals 4? Well, yes.
Oh, okay. Cool.
So f of x, f prime of x, we know is 4x. We just solved that. So f prime of 4 is 4 times 4. So that is 16. Okay?
So you don't have to do the whole thing out again.
No, it doesn't matter. You'll get 16 either way. Okay, so I'm going to show you how that looks like on decimals. What are we actually trying to do? So I'm going to graph this one, 2x squared minus 3, and then let's look at what happens at 4. All right, so that's how you actually solve these questions. Do you guys have any questions?
Is it always going to be like x? Wait, no, that's a dumb question. Actually, yeah, no, that's a dumb question.
Okay. All right. So what's going to happen is you're going to go home and the video is going to be the rest of this section. So that's due before Thursday at 8 a.m. So go home and watch the rest of the lesson, take notes. And then Thursday when we come to class, we're going to do the interesting derivative questions in class. So like really kind of out of the box stuff. Okay. All right. That's it for today.